1.7 is on the midpoint and distance formula. So I don't think that these two formulas are too hard to memorize, but you have to kind of know the process that's leading to these formulas. So we're going to talk a little bit about where these formulas come from. All right, Rhett, can you put that away? So it says the midpoint formula is a really easy formula. All we have to do is find the average of our x values and the average of our y values. So for instance, let's look at a picture so you guys can figure this out. If I have negative 3, 5, 1, 2, 3, 4, 5, and I have 5, 1, negative 1 here, and I want to find the point that is directly between those 2 points, the midpoint. So a point somewhere on this line that's directly between them. It's basically halfway over for the x's and the y's. Okay, so what we're going to do is we're going to draw in a triangle. And we're going to talk about this triangle. Okay, the bottom of our triangle, we can count the number of units. So if I was over at negative 3, and I want to go all the way over to 5, how many units separate negative 3 and 5?
8.
8. Do you guys all see that? It's like 5 minus negative 3. Right, there's 8 units. So if I want to go halfway across, how many units should I go then? 4, okay? So what happens if I take negative 3 added to 5 divided by 2? What do I get?
Negative 4.
No.
1.
I get 1, right? I get 2 over 2, which is 1.
Do you still have extra copies of
Yeah, I
chapter
do.
2?
Yeah, I'll give it to you.
No.
Okay, that's going to be the x-coordinate of our midpoint. Okay, so we're basically going over to an x value of 1. All right, so let's think about that. All right, so if I go 4 units from, if I start at 5 and I go 4 units to the left, where am I at?
1.
1. If I start at negative 3 and I go 4 units to the right, where am I at?
1.
1. Exactly. Does this make sense? Okay, so if I had just found the average of those two x values, I would have gotten to 1. I would have gotten halfway between them. That's what an average is, right? Halfway between two numbers. All right, so let's try the next one. So this next one, we were at a height of negative 1, and we went up to a height of 1, 2, 3, 4, 5, right? How many units separate negative 1 and 5? 6 units. So we could do this one of 2 ways. So we could say, I'm going to start at 5, and I'm going to go down 1, 2, 3, halfway. Or I'm going to start at negative 1, and I'm going to go up 1, 2, 3, halfway. Either way, so if I do 5 minus 3, I get 2. If I do negative 1 plus 3, I also get 2. So I'm at a height of 2. Okay. Well, what was the y value? So if I took my y value, and I took my negative 1, and I added 5 to it and divided by 2, what do I get? I get 4 divided by 2, which is 2. Doesn't that give me the same thing? Okay, so the midpoint formula, the quickest way to do it is just to find the average of the two x values and the average of the two y values. And we write it as a point. So we write, how do I find the average of two numbers? What do I do to them? I add them together, and then I divide by 2, right? So I'm going to write x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So average of x's, average of y's. That's the formula. All right, so number 1, it says find the midpoint of a segment with endpoints A and B. So we don't have to sketch it out. We don't have to see the picture. We don't have to think how many units separate the x's, how many units separate the y. All we have to do is find the average of our two x values and the average of our two y's. So if I take my x values and add them together, I have negative 3 plus negative 5 divided by 2. So average of the two x's. And my average of my y's is 4 plus negative 2 divided by 2. This is going to be m, which stands for midpoint. A little m stands for slope. Do you guys remember a little m from algebra? So we're using a capital M. So when we do this, we get negative 8 divided by 2, and we get 2 divided by 2. So our midpoint is what?
Negative 4, 1.
Negative 4, 1, exactly. So let's kind of look at it. Sometimes you can kind of see the midpoint without even doing any work. What's halfway between negative 3 and negative 5? Yeah, what's between negative 3 and negative 5? Negative 4. That makes sense to us, right? And then it's saying, well, what's between 4 and negative 2? That's a little bit harder for people. But think about it. Between 4 and negative 2, how many units are there? There's 6 units. So if I go 3 units towards the negative 2 from 4, I'm at 1. Does that make sense? Do you guys all see it? Okay, so the next one. So we have our midpoint is going to be negative 1 plus 3 divided by 2, and 5 plus 7 divided by 2. So we get 2 divided by 2, which is 1, and we get 12 divided by 2, which is 6. So our midpoint is 1, 6. All right, easy enough. We like midpoint. All right, now I'm going to make it a little bit harder. Are you ready for it? So find the endpoint A if you are given the midpoint. So if we have one of the endpoints is negative 1, 5, and the midpoint is 3, negative 5. So, you know, qualities of a good math student. Like, you can always figure this out. You could sketch things out. You could say, so if I was sketching it out, everybody look up here. I'm not going to tell you to do it this way in your notes because there's an easier way. But I'm going to show you what this picture looks like. So if I was at negative 1, 5 as one of my endpoints B, and I was at 3, negative 5, 4, 5, as my midpoint M, that's the middle, right? So I would have to go down and over to get to the other endpoint A, the same amount. Do we agree? You guys could figure that out because you could say, oh, to start at a height of 5 and go down to negative 5, I had to go down 10 units, right? Wouldn't you have to go down another 10 units to get to A? Yeah, so what height would that be at then? Close. Negative 15, right? Because we started at 5. So if we start at 5 and we go down 20, we're at negative 15. How about the y's? Or the x's, I mean. If I started at negative 1 and I went over to 3, I went over 4 units, right? Negative 1 to 3. How much do I have to go over again to get to A? I have to go over another 4, right? So if I start at an x value of negative 1 and I'm going over a total of 8, where am I going to be? 7. And some of you guys can totally get this. You can sketch it out. You can count things out. Never like think, oh, I don't know the formula. I don't know how to do this. You guys can figure it out. You can always think about it, right? And so on things like the SAT, if you can use those good logical thinking skills, it helps out a lot. All right, so here's the trick. Okay, and there's a way to do this with x's and y's too, but I'm just going to show you the trick. Okay, we have the middle. We have that the middle is 3, negative 5. And we have one of the endpoints is negative 1, 5. We want to find A. How much did I change M? What did I do to M to get to B? What do I do to the number 3? How do I adjust it to get to negative 1? I subtract what? 4, right? Does it make sense? I subtract 4. Do we agree?
Yes.
Okay, that means I want to subtract 4 from A to get to 3. So in other words, if you want to go backwards, because you're like, oh, I want to go back to A. Let's say, how do I go from B to get to M? I add 4, right? How do I go to M to get to A? I would add another 4. What should my A be then? 7. Do you guys see it? So let's start at the bottom. If I'm at 5 and I'm trying to go to negative 5, how do I adjust it? I subtract 10, right? Close. And then I do it again, right? So I subtract 10 again. So where am I once I subtract 10 from negative 5?
Negative 15.
Negative 15. Is that the point that we had? Totally. Yep. Is this the same process that we did in the picture?
Yes.
Yeah, we added 10 out of 10, right? Same thing. Okay, so let's try it again. So the midpoint of xy is M, which is 3, negative 4. So let's put x and y on there. Y is negative 3, negative 1. We want to find x. Okay, so we go backwards. So if I start at negative 3 and I'm going to 3, I added 6. If I want to add 6 again, I'm going to be at what point, or what x value? 9, right? On the next one, little tricky. If I start with -1 and I want to go to -4, what am I doing?
-3.
Yeah, I'm subtracting 3. If I want to do it again and I subtract another 3, -7. Do you guys understand the process? All right, you guys try the next one. So it doesn't matter which order you put your J and your K in. So if you flip those, that's fine. Just think about how you're adjusting to go from J to M. Okay, this one's a little tricky because we have a fraction. All right, so how about the first coordinate for K, the x coordinate? What'd you guys get for that? Cam?
-2.
-2, do we all agree? -2, yep, because we subtract 2 again, so we're at -2, I agree. All right, who thinks they're up for this challenge? Yeah, did you do it as a decimal? Did that help? Okay, so what did we add to both sides? So we add, or to each piece, we added 2.5, did you do that? So when you added 2.5, what'd you get?
I was still working on that.
Oh, you were? Okay.
But I think it's 3, isn't
It is 3, perfect, yep. So it should be -2, 3. Perfect. Does everybody understand that process? Easy, right? All right, Pythagorean Theorem. So all of you guys know what the Pythagorean Theorem says. What does it say?
A squared plus B squared.
A squared plus B squared equals C squared. But what if I was a tricky geometry teacher, which I often am? And what if I drew this? What would it be then?
A squared plus C squared.
A squared plus C squared equals B squared. So we have to be very careful. When we do A squared plus B squared equals C squared, we have to say something about C being the hypotenuse. So where C is the hypotenuse. Do we all know how to spell hypotenuse? I always say it'd be fun to have like a mathematical spelling bee where you get to spell things like perpendicular, parallel, hypotenuse.
That'd be fun.
Yeah, I see lots of errors a lot of times in math. All right, so we have A and B, and those ones can be either one, either of the legs, right? So A and B are the legs, and C is the hypotenuse, which means that we have a right triangle. When we use the word hypotenuse, it's always the thing that's across from the right angle. So it says find all missing side lengths. Right answers as simplified radicals and also rounded to the nearest tenth. Okay, so in this first one, we have 7 and 8. So I can call this A, B, I can call X if you want to. It doesn't matter. Let's call it X. I don't like A's and B's sometimes because A's look like 9s for some people's handwriting. Okay, so I have X squared plus 7 squared equals 8 squared. So I get X squared plus 49 equals 64. So when I subtract 49 over, X squared equals 15. So X is equal to the square root of 15. All right, does that simplify down as a radical? Can I write like 2 root 3 or anything like that? No, there's no factors that are perfect squares for 15. So we leave it a square root of 15. But I also said, also rounded to the nearest tenth. Do we know what a tenth is? So go ahead and put square root of 15 into your calculator. So when I do, I'm getting the number 3.872983346. It goes on forever. It's an irrational number.
It's 3.9.
Yeah, so if I'm rounding to the nearest tenth, I want to look at that 8 and decide if I'm going to make the 8 a 9 or keep it an 8. So we're keeping it, or we're making it a 9, right? Do you guys see that? Y'all remember how to do that? So we get 3.9. All right, so next one. So we're finding all missing side lengths. So I need to find this one here, B to D. So I'm going to call that X. And let's find this other one, A to B, Y. I'm going to find both of them. So what do I have to find first? Yeah?
The right, like the triangle on the right.
Yeah, I have to use that triangle on the right to find X. Do you guys see that? So I'm going to ignore all these lines over here, like AB and AD, and I'm only going to look right here. So when I only look at this triangle that's over here on the right side, I have 3 squared plus x squared equals 5 squared. think we talked about this the other day, didn't we? Did I tell you about 3, 4, 5 right triangles?
Yeah.
Yeah, so basically we get 9 plus x squared equals 25. So x squared equals 16. So x is 4. So this is a common right triangle in geometry. So we'll often have 3, 4, 5 right triangles. Okay, and any multiple of that will also work, yeah.
So do we choose a triangle, or is it just
We have to do that one because the other one, we only had one side. We only had 7.
okay?
So we got to get that first one. We got to get 4 first. All right, so as I was saying, any multiple works as well. So what if I multiplied all these numbers by 2? Then 6, 8, 10 would also be a right triangle. That works out in the Pythagorean theorem. So not all things. Like some people are like, oh, does 2, 3, 4 work? No, this is just a special one. 3, 4, 5. 3 squared plus 4 squared equals 5 squared. But 2 squared plus 3 squared isn't equal to 4 squared. So some of them work, some of them don't. It's called a Pythagorean triple. All right, so x was equal to 4. And now we go to this other triangle, so the one on the left-hand side. So the one on the left-hand side, we now have 7 along the bottom, and we have 4 for the height of the triangle. So we can find y. So we're going to say 7 squared plus 4 squared equals y squared. So we have 49 plus 16 equals y squared. So what do we get? 65 equals y squared. And 65, you can try to break it into its factors as well, like its factor tree. We'd have like 5 and 13. That's not going to go down any further, right? So y is going to be equal to the square root of 65. My 5s are terrible. Which, on my calculator, I get 8.0622577748. So what am I writing? 8.1, right? And I'm going to use the little approximation sign, approximately 8.1, to show that I've rounded that. Does that make sense? All right, so you guys try this next one. So the first thing you need to find, do you guys see what segment you need to find first? The BC, so we'll call that x. And then once you find that, you can find the length CD. So go ahead and try to do that. All right, so the first one we're going to find is actually a multiple of 3, 4, 5. However, it's not in the right order. Like if it had been 9 and then 12 was the other leg, it would be a 3, 4, 5. It would be 9, 12, 15. But no such luck, right? So it's a little bit gross. So we have 9 squared plus x squared equals 12 squared. And so we get, let's see, 81 plus x squared equals 144. So when you subtract the 81 over, what did we get there? 63. So we get the square root of 63, which we can actually simplify. How can we simplify that? Because 63 has 9 that goes into it. 3 squared is 7, perfect. And we're going to also approximate that. So you can just do square root of 63, or you can do 3 times the square root of 7, and you should get 7.9 for your approximation. Did you guys get those for x? All right, so then once we find y, well, y is going to be, so we do y squared plus x squared. Now, what's square root of 63 squared? 63. So it's kind of convenient in this problem to go back to the square root of 63 instead of writing it as 3 root 7. But if you did have something that was like 3 root 7 squared, do you guys know how we would square that? We would square the 3 and get 9 and square the root 7 and get 7, and then we'd multiply them together. So we'd still get 63. All right, and then equals 11 squared. So 121. So we have y squared plus 63 equals 121. So 121 minus 63 is 58. So y is going to be the square root of 58. Did you guys try to break it down? It's 2 and 29, so it doesn't go any further. 29 is a prime number. So then we would just say, which is approximately 7.6. Did you guys get 7.6? Awesome. Good. That's as hard as they get. Can we handle those? All right, if you can do that, you can do anything. All right, so let's go on to the distance formula. So the distance formula is the formula that is always much harder for students to remember, okay? So I'm going to show you a couple different ways to do these problems. So it's related to the Pythagorean Theorem. So it says, remember, you can always find the distance between 2 points by plotting them, drawing a right triangle, and using the Pythagorean Theorem, or you can just use the formula. So if we go back to that picture that we had before, right here, And I have those 2 points. So let me kind of get rid of some of these numbers here. And I want to find the distance between those 2 points. Basically what I'm asking for is the length of this blue line that I have drawn in. Okay, and we can use that little triangle that we drew before. So we go straight down and straight over, creating a right triangle. So if I want this length of the blue line, couldn't I just do the Pythagorean Theorem to get it? Okay, so if I was going to do that, we said that there were 8 units separating -3 and 5, right? And there were how many units separating -1 up to 5? There were 6 units there, right? Can you guys all find the length of the blue line then? Yeah, 6 squared plus 8 squared equals our distance squared, right? So 6 squared is 36 plus 64 equals d squared. So d equals whatever the square root of 100 is, which is 10. We did it. Do you think you could all do that on the test? Yeah, did you have to know the distance formula in order to do that? No. So what is the distance formula? So our distance formula looks like this. D is equal to the square root of y2 minus y1. Oh, hang on, let me do my x's first. Doesn't matter, but we'll do x's first. So x2 minus x1 squared plus y2 minus y1 squared. So what we're saying in the picture is that we're finding the distance between our x's. So if I had x's that were at, what were those points at? Again, let's go back. I know I keep going back and forth, but I'll go back to that. So if I had x's that were at -3 and 5, I get the 8 by doing 5 minus a -3. Right? Do you guys see that? 5 minus -3 gives me the 8. I get the y by doing the top 5 minus a -1, which gives me 6. Do you guys see that? That's where that's coming from. And then I take those numbers that I found, my 8 and my 6, and I square them and add them together. Right? So where does the square root in the distance formula come from?
C squared.
Yeah, it came from like our c squared or d squared in this case, right? So we took our d value and when we wanted our just plain distance, not d squared, we had to take the square root. That's where all that's coming from. Okay? It is just the Pythagorean theorem. So it's written a fancy way, but it's the Pythagorean theorem. Okay, so it says find the distance between points A and B. Right answer is a simplified fraction or simplified radicals and also rounded to 3 decimals. So you can call this x1, y1 if you want, and x2, y2 if you want. But really you're just taking your 2 x values and you're subtracting them. So you're going to have 0 minus a -3, and then we're going to square it. And then we have 4 minus, I guess I did it in a different order than before, but that's okay. There's a plus in between it. It doesn't matter. No, I did do the x's first, didn't I? Okay, we're good. So I have 0 minus a -3, and then I do 4 minus 0. All right, so what I get is 0 minus a -3 is 3. So 3 squared plus 4 squared. So I get the square root of 9 plus 16, which is 25. So my distance is 5. Done. So if you were a good test taker and you got stuck and couldn't remember the distance formula, you would plot it out and you'd be like, oh, I'm at -3, 0, and I'm at 0, 4. I want to find the distance between them. Well, I know this is 3, I know this is 4, so this distance has to be 5, right? So you don't even need to know the distance formula. I mean, eventually you should probably know the distance formula. All right, so here we go. So our distance here is going to be our 2 x values subtracted. So I'm going to do 4 minus a -1, and I'm going to square it. And then I do 8 minus a -4, and I square it. So if you don't like all of these negatives, you can do kind of similar to what we did with the midpoint. And you can say, how do I change it when I'm going from -1 to 4? I add 5, right? How do I change this when I go from here to here? I add, what do I add? 12. That's what these numbers in here are. It's 5 squared plus 12 squared. And if it had been negative, you're going to square it anyway. So we get 25 plus 144. Colin, put that away. So I get the square root of 169, which is 13. That's our answer. So quick note, what a lot of people do, especially in like Algebra 1, when they see this, they're just like, oh, that's equal to 5 plus 12. Those are not equal. All right, this we just showed was square root of 169, which is 13. Is that the same as 17?
No.
No, different numbers. Can't do that. Can't just take the square root of each individual thing. There's a plus combining them, okay? So cannot do that. All right, so next one has decimals. Same idea. Okay, so we're going to do negative 4.5 minus a negative 3.5. So it's going to be plus 3.5, right? And then I have 10.2 minus 7.2. So I get negative 1, but it's being squared. And I get 3, and it's being squared. I forgot my square there.
Would that also be a subtraction sign between the 4.5 and...
Yeah, it's like a minus a negative, so I just made it a plus.
Oh, okay.
Sometimes I get lazy. Maybe I should not take shortcuts. All right, so I get 1 plus 9 under square root, so I get the square root of 10. So that's our radical, and it's simplified. It doesn't go any further. So if I find the square root of 10 on my calculator, it's 3.2 then. Okay. Approximately. Round is the nearest 10. Oh, no, I said rounded to 3 decimals. You would have gotten a bonus point if you were paying attention and you corrected me. So what should it be? So not 3.2? 3.162 is what my calculator is saying. 162277766. Okay.
Wait, 1.227.
Yeah, it says 3.162277766. So we look here at this decimal, and it doesn't need to be rounded up. All right, and the last thing we have is the converse to the Pythagorean Theorem. So there's actually, like, we have the Pythagorean Theorem, which says a squared plus b squared equals c squared. But what if they're not equal? So what if c squared is greater than, or less than, or whatever? So the key to this is to put the c squared first. So if you do the c squared first here, it's kind of nice because when you have less than, it's going to be acute. And when you have greater than, it's going to be obtuse. Doesn't that make sense? Less than, acute. Greater than, obtuse. So if you put the c squared first, it really helps us out here. So which one would be our c in number 1? What's the biggest side? 17. So we're going to start it out with 17 squared, and we're going to see what happens here. So I'm going to do like a little box with like a question mark. Is it equal? Is it greater than? Is it less than? And we have 12 squared plus 9 squared. So 17 squared, does anybody know their squares? 289. Sycamore students always have to memorize their squares. So 144 plus 81 over here. So I get 289. How is that related to 225? Greater than, less than, equal to? Greater than, right? So what would we say is this triangle right, acute, or obtuse? So based on that little thing, it was greater, so it's obtuse. Right? That's why it's nice to put the c squared first, like I was saying. So let's go through this on this one. So I have 20.1 squared. I want to see what's happening here. So I have 18 squared plus 9.6 squared. So when I do 20.1 squared, I get 404.01. Is that greater than, less than, or equal to 416.16? Less than. So what do we write? Acute. I'm guessing the next one's probably going to be right, but maybe I surprised myself here. We'll see. So what do we think? So we have 16 squared. I don't know. Is 16 bigger than 2 root 39? Let's put 2 root 39 in our calculator just to make sure. 2 root 39 is around 12.489 something. So it's bigger. Just because it looks like it's the, we don't know. Sometimes things aren't drawn to scale. Now this one's a little tricky, so I'm going to do 2 squared of 39, and then in parentheses, with parentheses around it, I'm going to do square. So everybody put that into your calculator and make sure you can get this correct. So when you do 2 squared of 39 and you square it, you should get 156. Did you guys all get 2 squared of 39 and then squared? Should be 156. So we have 256, and we're seeing if it's greater than, equal to, less than 256. So in this case, it's equal. So we get that it's a right triangle. Okay, did everybody check the 2 square root of 39 squared? So you either need parentheses on your calculator around it, or I would just do 2 root 39, hit enter, and then square that answer on your
How would
calculator.
you, like if you didn't have a calculator, would you just?
Yeah, if you didn't have a calculator, you would square the 2
39?
and square the square root 39, so you'd have 4 times 39, exactly. Which you could do in your head, right? Because we talked about multiplying by 4. So double 39, what do you get when you double 39? Almost 80, 78, and then double that. So what do you get when you double 78? 156, exactly. So all these calculator skills without using a calculator, right? We're good. All right, and the last thing is congruent segments, so segments that are the same length. So we've already actually talked about congruent segments, but we might need to use the distance formula for that. So it says plot the points -1, 1, -4, 3, 3, 2, and 2, -1. And then it says draw in AB, AC, and AD. Find the lengths of AB, AC, and AD. Are any of the segments congruent? So if I'm finding the length of AB, if you already have a grid, it's much faster to not use the distance formula. So everybody look up here. With AB, I have 2 units up and down, 3 units right and left. So if I have 3 and 2 like this, it's not a 2, 3, 4 or anything like that. That doesn't exist. But we can find that distance x by doing 2 squared plus 3 squared equals x squared. It's much faster. What's 2 squared plus 3 squared?
4 plus 9.
4 plus 9, which is 13. So that means x, so the length of AB would equal square root of 13. Does it make sense how I did that? Use the picture to help you. It makes things much easier. So if I have AC, then that's going this way. So let me draw my little, draw this out a little bit. So I have 1 unit, and then I have, what is that, 4 units there? Can you find x? 1 squared plus 4 squared equals x squared. 16 plus 1, 17, so we get AC is equal to the square root of 17. Okay, so don't go through all those steps with the distance formula if you don't have to. And then the last one is AD. So we're going down and over. That's also down 2 over 3. So what should it be? Didn't we just do one like that? Yeah, square root of 13. So that means that AD is congruent to AB. They're the same. All right, are we good? Feel good about distance formula, midpoint formula? All right, we're going to stop there.